Hi students, I wanted to show you how to do Lab 22.1 sequencing time from the Glencoe Geology, the Environment, and the Universe textbook. The most important thing to get you started in the right way is to start by reading the top of the lab. I know you probably want to gloss over this, but it has a lot of important information. Up in the materials, it's important to note that you do need a 2.5 meter long roll of paper. If you do not have like adding machine paper or receipt paper that you can do that, you can cut strips of paper until it's 2.5 meters long. That's a lot of strips of paper to cut, but I can show you how I do it in the next slide. And then also, you will need a meter stick, but any ruler that has centimeter divisions will work for this lab. Please pay attention to this page and plan on writing all over it. You will refer back to this page quite a bit. To make your long strip of paper, you can see I had scissors here and I neatly cut it, and then I took a regular 8.5 by 11 sheet of paper and I just cut it into strips and taped them together until I had a 2.5 meter long piece. It was a long piece of paper. Then I'm going to start by marking the paper. The first marking that you see here starts at 4,600 million years ago. So I wrote 4600 MYA, million years ago. I'm going to write that on the first division because over here on the paper, that is the very first marking that you make. Okay? And then from there, the lab actually tells you to make marks at every centimeter representing 20 million years. But I didn't want to do that. That was a lot of markings to make. So I actually made that at every 10 centimeters, I did 200 million years. So here is one of my marks. So this would be, if this was 4,600, this is 200 million less, so that's 4,400. And the next mark was 4,200, and then 4,000. So I made marks like that going all the way. Every 10 centimeters, I went down by 200 million years. So make sure you mark your entire paper going down the line like that, all the way to the end. Okay, the next piece that you're going to do, once you have those markings labeled all the way down your whole strip of paper, then you're going to start marking some of the numbers that we saw. So to mark this first one at 4,600, it's going to go on your very first marking. But to mark the second one ended at 2,500 million years ago. So you're going to go to your strip of paper, go to 2,500 million years ago, and write that early bacteria ended. Okay, early bacteria ended 2,500 million years ago. Then you're going to go back to your paper and you're going to see when early bacteria started. To find out, it said that it lasted for 2,100 years. So you're going to add those together and you're going to see that it started 4,600 million years ago at the beginning. So you're going to go to the very beginning strip of your paper and you're going to write start early bacteria. So it started at 4,600 million years ago and it ended at 2,500 million years ago. Okay? Then you're going to do that for all the other numbers. So I'm going to go up here one more time and show you this next number. It ended 540 million years ago. So at 540 million years ago, you're going to write multicellular organisms end. And then when did they start? You're going to go back to your paper and do 540 plus 1,960, and you're going to get 2,500 million years ago. And you're going to go to your paper at 2,500 million years ago and say, start multicellular organisms. Then you are going to continue until you have filled out the entire paper. When you have done the math here and you put the starting time of fish at 439 and the ending time of fish would be 439 plus 71 equals 510. So you're at the 510 mark, you're going to put that fish is started. You are going to fill that out all the way on your timeline till this whole thing is filled out, till everything on here is filled out. Then you are going to make your own timeline. To figure out your own timeline, you're going to figure out how old you are to the nearest 0.25. So if I am 10 years old and 2 months, then I'm going to round up, and that's why I have the squigglies, because that means about this much. I'm going to say that I'm about 10.25 years old. So round to the nearest quarter. Nobody in here is 10 years and 2 months, so I know that none of you could copy me exactly on this. But if you are about 14 and a half, then you will put about 14.5. You're going to take that number and you're going to take 230 and divide it by whatever number you have. Say it's 14.5. And you're going to get an answer. Take the answer to the nearest tens place after the decimal. So round it up. So for this 10-year-old person, their 1 year of life was 22.4 centimeters. So what I'm going to do on that, and yours will be a little bit less than that. Yours should be less than this. What you're going to do is you are going to write out on the other side of the paper your timeline. So your timeline is going to look something like this, where at 2 years old, so this would be about 44.8 centimeters of the way down for this person. They're going to be 2 years old, and then 5 years old. So you're going to mark your own timeline of how old you are. And remember that for like this person, 1 year of life was 22.4 centimeters. That's a long piece of the paper in order to be 1 year of their life. So you don't need to write interesting things that you were doing at that age, but if you wanted to, you can. But then you're going to spread your timeline across this whole piece of paper, okay? Then at the end of the lab, I want you to thoughtfully answer questions on the back. What can you conclude about the rise of living things? Did the rise of new organisms and the diversification of living things occur at an even rate over the history of the Earth? Did it happen at really regular intervals? I want you to thoughtfully answer that, and don't just give me a yes or no, because you are not going to get all your points on that. And then assuming that humans have been alive for 2 million years, to what length of time in your own life is proportional? Is that like 4 years of your life, or is that like a couple of months, or what is that in proportion to your life? Look at the timeline to answer that. On the last page, what's the longest division of time in Earth's history, and approximately what percent of Earth's history occurred during this division? So look at all of the things that happened during that division on Earth. Did very much happen? Did a lot of living things like diversify during that time period? It was a really long time period. What happened? Relate this long division of Earth's existence to your own life. About how many years of your life are proportional to the longest division of time on Earth's history? So look at that longest piece of Earth's history and see how many years that was in your life. And then about what percentage of the entire existence of Earth have bacteria been alive? So go and look through that, answer those questions, and I hope you enjoy this lab. Take care.